We spend our lives inside buildings, right? But how often do we actually think about the invisible systems that make them work? Behind these walls is this incredibly complex web of pipes and wires and supports. Today, we're going to follow the thread of just one single pipe to unravel a really fascinating design puzzle.
You flip a switch, you turn on a faucet. It feels so simple, right? Effortless. But that simplicity, it's the result of some serious complexity. Getting all of a building's systems to play nicely together, that's one of the toughest challenges in modern design, for sure.
So, what we're going to do is shadow a designer as they solve one of these puzzles, basically in real time. And what starts as this simple little task, it quickly turns into a high-stakes game of 3D chess. Okay, let's jump in. All right, so every design project, it starts with a goal. And in this case, the initial plan seems, well, perfectly straightforward. So, here's the mission, right? Connect the drainage for 3 essential fixtures: a shower, a toilet, and a kitchen sink. You look at it on a blueprint, it just looks like you're drawing a few lines. I mean, how hard could that possibly be? Okay, before we go any farther, let's talk about a key component you're going to see here, the P-trap. You've seen these? It's that simple U-bend under your sink or for a shower. It holds a little plug of water that acts as a barrier, and that's what stops all those nasty gases from the sewer line from coming up into your space. It's a really simple but absolutely crucial invention.
And this is where our story takes a turn. This is that moment where a simple plan smacks right into a complex reality.
So when you think about it, the most logical path for the kitchen sink drain is, well, of course, straight down. I mean, it's the shortest, most efficient route to connect with the main drainage line below.
But just as the designer is modeling this in their software, a big red flag pops up. That perfect straight path, it's completely blocked.
And this is that exact uh-oh moment of discovery. It's not an error in the software, it's a real-world constraint. The building's own skeleton is literally right in the path of the plumbing.
And what's so interesting here is that it's not just any obstacle. It's a W18 by 55 structural beam. This is a critical piece of the building's support system. You can't just move it, and you definitely can't drill a hole through it. The plumbing has no choice. It has to adapt. So, the puzzle is set. How do you get around an object that you cannot move? This is where the real design work, the real problem solving begins.
And the solution is actually pretty elegant. First, the designer reroutes the pipe horizontally, right? Just enough to clear the beam's width. Then, using 2 really precise angles, they create this vertical offset to drop the pipe down and align it perfectly with the connection point below. It's a neat little maneuver.
Now, you might be thinking, wait a minute, why not just use a sharp 90-degree elbow to make that drop? It seems more direct, right? Well, there's a very specific and very professional reason for this choice.
And this right here is a perfect example of designing for the long term. See, by using 2 45-degree bends, you create a much gentler slope for water and waste, and that drastically reduces the chance of clogs down the road. It also means the designer avoids having to add what's called a cleanout. That's an extra access port, which saves cost and complexity. It's just smarter engineering.
Right, and believe it or not, that beam wasn't the only piece of the puzzle. Not by a long shot. A building is this dense web of interlocking systems, and a good designer has to be able to see all of them at once.
Yeah, this is really where a designer earns their paycheck. It's not enough to just solve for your own pipes. You have to solve for the structural engineer's beams, the mechanical engineer's ducts, and the electrician's conduits, and they're all competing for the same few inches of space inside the walls.
So, to make all these connections actually work, you need specific fittings, like this one, the sanitary T. It lets a horizontal pipe, say from a sink, flow smoothly into a vertical drain stack, directing the flow downwards just where it needs to go.
So, get this. Just when the beam problem is solved, another obstacle pops up. The proposed path is now blocked by a piece of mechanical equipment, in this case, a heat recovery unit for the building's HVAC. So the pipe needs, you guessed it, yet another detour to snake around it.
And this right here, this just brilliantly illustrates the core challenge. On paper, everything is simple, clean lines. But in reality, it's a 3-dimensional chess match. You're trying to fit pipes and ducts and wires and structural supports all together perfectly.
Okay, so with all the big obstacles navigated and those clever detours planned out, let's move to the final stage and see how this whole intricate network finally comes together. So with that main path now clear, the designer can finally lock in the network,
connecting all the individual branches into one cohesive system. Each piece has to be so carefully aligned and connected to make sure you get proper flow and function.
So what started with just those 3 fixtures, the shower, toilet, and sink, has now expanded to include the washer, the dryer, and the bathroom sinks, creating this fully integrated drainage network for the entire space. And this is the final product, a system that was literally born from problem-solving and expertise. It's completely invisible to the people who live or work in the building, but it is absolutely essential for the building to even function. So the next time you're just sitting in a room, take a second. Think about the complex dance of systems that is happening just out of your sight. Every single building is a collection of solved puzzles. And now, you've seen exactly how one of them was put together.